Hello, good morning, students. When you have a question like this, if you look at it, it's actually a question that has to do with longitude and latitude. The great circle and the small circle. The question is on the board. I'm going to read out the question even while you're looking at it. When you have a question like this, before you solve the question, you need to draw the diagram of this particular question. You illustrate it on a diagram. And if the diagram is correct, it's going to attract at least 1 or 2 marks. But before I continue, if you're just new to this particular channel, you can subscribe to the channel you are watching now is Casey White Math Solution. So follow me as I am going to analyze this question to the end of it. So follow me as I'm going to analyze this question. I'll start by drawing the diagram. So what I'm going to do now, I'm going to draw a circle. Then I will represent these broken lines as my greenish meridian and this as my equator. Then I will name my circle. I'll fix this cardinal point. This is the north. Now let me bring the diagram a bit. Let me bring it down a bit so that you can see it clearly. So I am bringing the circle down here. Now this is my north. This is my south. This is my west. And this is my east. So this is my equator and this is the Greenwich meridian. And the question is, P and Q are two places on the same parallels of latitude, 34.6 degrees south. I will come down to the south here. The latitudes are imaginary lines running from the east to the west, and they are also known as small circles. So I will label it as 34.6 degrees south. Then we're told that their longitudes are 28.7 degrees east. 28.7 degrees east. You come to the east. And this is 28.7 degrees east. And we also told that the longitude again is 11.3 degrees west. See it here. This is 11.3 degrees west. This I told you that it is, let me put it here so that you can see it clearly. This is 28.7 degrees east. All right. Now we are told that these are points. They said P and Q are two places on the same parallels of latitude, 34.6 degrees east. And their longitudes are this and this. Now, where this longitude actually cuts this latitude is a point. Where it is cutting, like there is a point here, there is a point here. We need to know the one that is P and the one that is Q. So we're told that the numbers were given respectively, meaning that the first one is for P and the second one is for Q. So our P is on longitude 28.7 degrees east and latitude 34.6 degrees south. So this is my P. And we also told that our Q is 11.3. Our Q is 11.3. We also told that our Q is 11.3 degrees west. So now this is my Q here, 11.3 degrees west. Then I will find the distance along the parallels of latitude as we were instructed in the question. We said we should find the distance between P and Q along the parallel of latitude. So I am creating a diameter for this latitude. So I will trace this particular point. That's how to solve the question. This is the point, this is the point. Since we are considering a latitude and not the equator, so we'll trace it to the latitude. So I will trace it here. I will equally trace it here. So this is going to give me a sector. So this sector now, this is a sector. Now I am going to solve this sector. And when you're finding the distance along parallels of latitude, we have a formula for it. And likewise, when we are finding the distance along great circle. So along parallels of latitude, the formula is given as distance Q, PQ, distance PQ as required is equal to theta over 360 times 2 pi small r, 2 pi small r, where 2 pi small r, 2 pi small r, 2 pi small r, where r, small r is equal to big R cos theta prime, cos theta prime. My theta prime is the latitude, and theta prime is the latitude. The latitude in this case, which is equal to 34.6 degrees. 34.6 degrees. And I don't want you to get it twisted. That is why I separated this theta as theta prime and this one as theta. This theta now is the longitude difference. Theta is the longitude difference. So theta is the longitude difference. Longitude difference is the longitude difference. And since the longitudes are on opposite sides of the Greenwich meridian, so we add the longitude together to get the longitude difference. But when they are on the same side, the both longitude are on the same side, either the west or either the east, we subtract it to get the longitude difference. But in this our case now, they are on opposite side of the Greenwich meridian. One is on the east and the other one is on the west. So we are going to add to get the longitude difference. So I am going to add, that will give me 28.7 plus 34.6. So when you add these two together, you're going to get 40 degrees. You're going to get 40 degrees. You're going to get 40 degrees when you add these two together. Then we are going to substitute this now into the formula. PQ, as I told you, PQ is equal to 40 over 360 times 2 times pi times 22 over 7. Recall that we said we should use our pi as 22 over 7. Pi as 22 over 7. Excuse me, let me write it in such a way that it will take this page will be okay to take everything. I'm going to reduce my lettering a bit, please. So this will give me 40 degrees over 360 times 2 times 22 over 7 times big R, which is 6,400, I told you, then cos 34.6 degrees. Cos 34.6 degrees. Cos 34.6 degrees. So when you evaluate this, when you evaluate this, you're going to arrive at, if you use your calculator to evaluate this, you're going to have arrived at 3679 3679.237, which is approximately 3679 kilometers to the nearest kilometers. So that is how to solve the first part of the question, which is distance along parallels of what? Latitude. Distance along parallels of latitude. That is how to solve the first question there, which is distance along parallels of latitude. Now we move to the next one. Recall that I told you that we have three questions here. We have done the first one. The second one is the shortest distance between P and A on the surface of the Earth. The shortest distance between P and A. Now, where is my A? Where is my A? The shortest distance between P and A. Shortest distance between P and A. They say A is another point on the same meridian. A on the same meridian through P. So A is on the same meridian through P. So we come to this point here, and is the north. So that is going to give me 25.4 degrees north. They say it is through P, through longitude P, and the latitude of it is 25.4. So this is A, 25.4. So now, since we are looking for the shortest distance we trace it to the equator. That is where we get the shortest distance through A. So now we have gotten, this is another sector we are looking at. We are looking at another sector AP now. Now we have to calculate the distance from here to here, and that is the shortest distance from P and A, between P and A on the surface of the Earth. Between P and A on the surface of the Earth. So I am going to clean this part of the board. Please, I'm going to take it out gently. Kindly bear with me. The essence of doing that is for us to have enough space so that we can finish our question. All right, thank you very much. So I am going to continue the solution up here. Now, since we are calculating the distance along the parallels of longitude now, or the distance along a great circle, we use the formula. The formula we are going to use now is going to be PA is equal to, the formula now is PA, that sector PA is equal to theta over 360 times 2 pi r. This time we use the big R because that's the radius of the Earth. Since we are referring to the equator, we are talking, the equator is the center of the Earth. So the radius of the Earth now is R. The equator is just an imaginary line that divides the Earth into two equal parts. It's assumed to be the diameter of the Earth. So the radius of the Earth is R, which is 6,400 kilometers. So this theta now happens to be the latitude difference. Theta is the latitude difference. That the difference between this latitude, 25.4 degrees. So we call this theta is the latitude difference, which is equal to 25.4 plus 34.6. Now, the reason why we are adding, we discovered that both latitudes are on the opposite side of the equator. And when we have a situation like that, we add to get the latitude difference, just like what we did in the longitude difference. So we do that same one for the latitude difference. So invariably, what I'm trying to say is that when the latitude or the longitudes are on opposite sides, we add to get the longitude or latitude difference. But when they are on the same side, we subtract to get the latitude or the longitude difference. Please kindly take note of that. So when we add these two together, 6 plus this, 34 plus 25, this, we add this, so we are going to get what? Theta is going to give us what? 60, because 25 plus 34, 20 plus 30 is 50. 5 plus 4 is 9. 0.4 plus zero point 0.6 is 1. So that will give us 60 degrees. So that will give me 60. It will give me 60 degrees. So I am going to substitute that into my formula. I will say PA is equal to 60 over 360 times 2 times 22 over 7 times 6,400 kilometers. And when you evaluate this with your calculator, you are going to get 6704 6704.76. So to the nearest kilometers, it will give us approximately 6705 kilometers. So this is how to solve for the distance, the shortest distance between P and A. The shortest distance between P and A. This from here to here, that's what we are talking of here. Because we are told in the question that A is on latitude 25.4 and on longitude 28.7 degrees east. So now this is how to solve the question. Now what you can take out of this is that I have made use of two different formulas here. So the first one, I made use of theta, that's theta over 360 times 2 pi small r. The reason is because I was calculating a distance along parallels of latitude. Now in this case, I am using the big R. Why am I using the big R? I am using the big R because I am calculating distance along the parallels of longitude. That is why I am using the big R. So that is how we use the formula. The last question we have here now is we should find the circumference of the circle of latitude through A. The circumference of the circle of latitude through A. So please, I am going to clean this part of the board so that I can solve the last question here on this part of the board. This indeed is a very, very, very interesting one. Indeed is a very interesting one. So I'm going to solve the last question here, which is the circumference of the circle, and that is C. That is C. We know that the formula for the circumference of a circle is given as circumference is given as 2 pi r. 2 pi r. Now in this case, since we are referring to the latitude there, so our r, small r now, is equal to big R cos theta, where theta is the latitude. Where theta is the latitude. Theta is the latitude, which is 25.4 degrees. That's theta is the latitude. Therefore, circumference now will be equal to 2 times 22 over 7 times 20, 2 times, then times 6,000. Okay, let me write it so that everything will enter properly. This, I'm taking it here so that everything will enter properly. Circumference is going to be 2 times 22 over 7 times the 22 over 7 is the pi, then big R, which is 6,400, cos 25.4. So when you use your calculator to solve this question out, when you solve it using your calculator, you're going to have 36339, 339.88. So which can be seen as 3, 6. I'm approximating this now. So when I approximate this 3, I approximate this, it will change to 0, and this will come to 4. So 340 to the nearest kilometers. To the nearest kilometer. So interesting, you can see how we've been able to solve this question. And this is actually a WAEC question. So when you have a question like this is how you approach it. So in case the white math solution, we solve questions like this. We solve questions like this. We break it down for students to understand. And we also have a live class. A live class that if you want to join our live class, you just indicate interest on the comment section. Indicate interest so that we'll tell you, we'll give you access to the live class. So when you come, you'll be able to ask questions, you'll be able to share things with us in the class, you'll be able to understand better. For now, try as much as possible to subscribe to this channel. Thank you very much for your time. This is Casey White Math Solution.